Hi, everyone. Welcome back to Uddering Engineers. We are a podcast created by engineering students for engineering students. My name is Patricia. I am a second-year electrical engineering student here at the Schulich School of Engineering. In this first episode of the first-year courses series, we are going to talk about Engineering 233. Today, we are joined by Dr. Mohammad Moshirpour, who is an instructor and coordinator for the course. So, Dr. Moshirpour, do you mind briefly introducing yourself?
Oh, hello everybody. My name is Mohammad Moshirpour. I'm an instructor and a Schulich chair in software engineering at the University of Calgary. I teach a variety of different programming and software engineering courses, namely Engg 233 and the ENSF 409, which is Principles of Software Development, software architecture, software testing, and I'm also the director of the new Engg in software engineering program.
So how long have you taught the course? As I understand it, this course is taught using the flipped classroom format, correct?
That's right.
Why was this implemented, and what changes have been observed since implementing it?
Absolutely. So I'll give you a little bit of a story to address your first question with regards to how long I've been teaching Engg 233. So I started teaching Engg 233 in fall of 2012. So this was when I was a graduate student. So I wasn't a professor yet. I was still doing my PhD at the time, and it was the second course I ever taught. So it was, I never forget the experience where I went in the lecture. There was a huge lecture hall with over 200 students. It was my basically first teaching, second teaching experience, but for that big of a classroom, the first teaching experience. And it was just quite interesting. And we used to teach C++ back then, and I kept teaching that until 2015. So in 2015, I was approached by the school with regards to the idea of changing 233 to make it a little bit more creative. And we had a team. It consisted of me and Dr. Emily Marasco. We were both graduate students at the time, and we were tasked with flipping the classroom. And that means that's a teaching module. That's a teaching model that you would watch something or you would read something and you would come to class to practice rather than to learn. So you change your role as the instructor, as somebody who just talks at the student, to a coach, so that they know the material and you're going to do problem solving for them. So it's a very powerful teaching approach, so that I'm sure students, you've all been in that situation where you show up to a lecture as almost like a deer and headlight situation, where you just sort of show up and the professor starts teaching, and sometimes it can feel like drinking from a fire hose. And a lot of the instructors, professors, teachers in general, they advise you that, I'm going to talk about this concept, so make sure you read ahead. And by the way, that's a very powerful thing for you students to do. Two things: study the concepts before you come to class, so know what the prof is going to talk about. Just go over it really quickly, so you're not just blank when he's talking about things. So read the material before lectures, and then right after the lecture, spend some time and go through the material again. That's a very powerful way of doing well. So that's what Flipped Classroom does. And that's what we did. So I recorded videos. I remember this was in 2015. I was writing my PhD thesis and recording videos with lots of long nights. A true story, I actually took the clock at the bottom of my screen. I took it off because I didn't want people to see that I'm recording videos at like 2 a.m. And so it was a crazy semester. I was recording these videos, and we taught that course using processing, which is basically a tool that wraps around Java. So you're programming in Java, where you have access to very powerful graphics libraries. So you can just write Java and then see animations. So we taught this course starting 2015, and the course evolved from there. After the first year, we reflected what went wrong, what went right. We made the course better each semester, and the response has just been so positive. I'll give you a little bit of a background for this. So when I first started teaching 233 like regularly, the students liked me. I liked the students. My course evaluations were all fine. It was about, let's say out of 7, I was getting 6.3, 6.2, something like that. When we flipped it the first year and the second year, I got something like 5.8, which is still okay out of 7, but it wasn't as good as I was getting. And then after the second year, when we went into the third year, because we had really learned how to do it, my evaluations were, the student responses were overwhelming. I got, I was getting above 6.5, 6.6 out of 7. And last year I received ESS Professor of the Year for the entire first year cohort, which was a great honor, and I was very thankful for that. But I sort of took that from the validation from the students that they're really enjoying the course. Some of the reasons that maybe why the first couple of years it wasn't, the students were still struggling with the way the course was that the students were watching my videos, and then I would go to these in-person 1-hour lectures, and perhaps I was repeating too much of the videos then. But then from the consequent years, what I did was that I just trusted that the students know the material. And that's a hard thing to do, right? I trusted that the students know the material, and then I would come to lecture and I would just problem solve. So you know what? I've taught you loops. Now I'm just going to come and I'll show you examples with loops. And that was a scary thing to do, because I thought that, well, what if I'm losing them and they haven't watched the videos? And then I said, you know what? I'm just going to trust them. They have quizzes to answer anyway. So I'm just going to say that they do and do this. And then from there, it just worked really well.
Yeah, I think as a second year engineering student now, I think first year coming into first year and taking the course, actually 233 was one of my favorite courses, and one that I did
Excellent. That's great to hear.
very
Thank you.
well in. And I think part of that engagement was also due to the flipped classroom method. And I think that was my first year. That was the only flipped classroom environment that I had been in. And so it was kind of a different learning environment. And I think there's kind of a barrier where when watching you online was very, and seeing you in person for the first time was very surreal and weird. And I think because of COVID, this I'm sure is also a problem for many more students coming into class in person after a while of just seeing their professors in online.
I sort of talked about my experience back in 2012 when I went into my first 233 classroom, and I just loved it. I loved being able to help students succeed and help them teach and all that stuff. And this was a really, really good experience in general. And I really got hooked. I say that I didn't get into teaching because of grading, because I love to grade. I got into teaching because, I love to lecture and I love to have discussions with students. And unfortunately, this has been limited quite a bit due to COVID. So can't wait to get back to the classroom. But I think during COVID times, I definitely had an edge, perhaps compared to many other instructors, because I had worked online learning and I knew, what things kind of works and what doesn't work, and how important is that sort of human connection. When I was there's a professor in mechanical engineering that really helped me in creating these lecture materials for 233 back in 2015, and he really mentored me. Dr. Ron Hugo, who has a lot of videos in mechanical engineering, and they're all on YouTube, and his videos are really sort of world famous, and he's got like thousands and thousands of subscribers on YouTube, people who watch his videos. And I was really grateful to have him as a mentor. And one of the things that he said to me early on was that, you're recording these videos, but record yourself too. So it shouldn't just be you talking over your slides or your code or whatever. It should also be your picture there as well to personalize that experience. And I did that, and I think that made a huge difference because, as an instructor, when you communicate with your students, you need to be able to really be able to connect to them. that connection is huge, and it's more difficult to do it in university when you have 200 people in front of you. It's harder to connect to them, but making that connection is so important. And I think people who are really successful in teaching, they do that. They're able to sort of reach out and get to know their students, and that's a big challenge that we need to overcome in COVID times.
Yeah, I definitely agree. So what is Engg 233 in a nutshell? Can you talk a little bit more of the structure and the final project that students get to do?
Absolutely. So Engg 233, it's Introduction to Programming. So if you come to Engg 233, and by the way, I'm a U Calgary grad myself, and I came to University of Calgary to get my engineering degree, and I had to take Engg 233. So I didn't know any programming when I started here, so a lot of students, some of them know programming, some of them don't. Engg 233 is the course that makes you programming literate. So you're going to be able to read code and you're going to write code, and that's a very good thing. I mean, it's a course that if you're a beginner, you don't really have to be intimidated by it, and if you know how to program a little bit, you're still going to be challenged by it. Our goal is to teach engineers the ability to read and write code and to be able to understand how computers work. And this is irrelevant. I mean, the language is a bit irrelevant as long as you know how to program. I mean, some languages are better than for some other things, but ever since I joined the 233 team, I've taught this course in C++, then processing, and now in Python. And the content is more or less the same. It's just that different tools in different languages, but the constructs are the same. So when you write program, the computers need to make decisions, if and else statements. The computers need to repeat tasks, loops. The computers need to modularize tasks, functions. So all those things are basically the same in all these different languages, but maybe how they're used. And the final project serves as that. So that's another teaching methodology that you guys should take a note of. So I talked about flipped learning. Even if the course isn't flipped learning, you should read ahead and exercise the flipped approach a little bit. The other thing is project-based learning, PBL. So PBL, I'm a huge believer of PBL, especially being a software engineer. I strongly believe that you learn by doing, and hands-on learning is everything. We are practitioners, especially software engineers. We are practitioners. We sit there and we build things with our own hands on the computer. There's no technicians or nobody else. We got to be able to do it. So PBL is extremely important. So in any course that I teach, 233, 409, 593, whatever, what I do is that I take a hybrid approach. In the beginning of the course, I do assignments. So I teach a concept, loops, you have an assignment on loops. I teach a concept, if and else statements, you have an assignment on it. And then at the end of the course, depending on the course, last 3 weeks or last 6 weeks, what I do, I say, okay, all these things that I taught, they all come together in this project. So you get to exercise everything that you've learned in this sort of mega project to do it. And I find that it works great because it's kind of like in any sport. So like let's say you're learning how to swim, they teach you all the motions. So you move your hand this way, you move your neck that way. So they teach you all of that, and now you go in the deep end and you're supposed to combine all those moves together, and that's where you learn. So there's individual concepts. Okay, you got the individual concepts. Now let's put them in practice in a bigger project. And PBL is where we win as instructors. That's where we can kind of see how our students do and if they're able to build stuff. And my teaching philosophy is basically given in one sentence. Engineers are builders, and that's it. So I'm in the business of training builders, people who can build stuff, that's why I do flipped learning, so I can have be more of a coach. Builders are supposed to be able to learn things on their own and know things. When you're trying to build stuff, you can't just like blindly put something in place. You got to examine stuff. Flipped learning really provides the students of that. And then project-based learning, you work on a project based on everything you have learned in the course, and then you got to practice your engineering skills. And then lastly, best practices, which is a key element in any practice. So any fool can write code. I mean, that's a quote from somebody that I'm stealing. Anybody can just write code, but to actually write it using best practices, that's quite another thing. Are you writing code that's easily tested? Are you writing code that's modular and can be reused, or do you just have this giant file that everything is in there and then you just don't ever touch it, because if you touch anything, God knows what happens. So best practices lies on top of project-based learning. So all in all, it becomes a very powerful combination to train engineers to be builders.
Yeah, for me, the hardest part of the course would probably be the project at the end, the final project. But it was also the most rewarding because well, in a sense, it's very different from the labs where you kind of have guidance all the way through. Well, with the projects, you do have guidance, but I think it was my first time actually doing a project from start to end, and even that I had help. I think also what's important is building confidence in, first year students like myself who never had to do any extensive coding projects before. And I actually still have my project from first year on my laptop in memory, just because I think it's something worth keeping.
Absolutely. And I mean, projects are extremely important, I think, in any concept that you are doing. Doing projects allows you to really go beyond the course and see all the problems that could appear. I mean, assignments are important, right? Like if I teach you something, I would like to give you an assignment so you can practice that one thing, right? But that's not how, and that's important. But assignments can be a little bit cookie cutter, right? Because this is one concept, you practice that. But then putting everything together, that's really, really important, and do it in an elegant way using best practices. That is really important. And I think at the end of the day, a lot of people apply to do, let's say, summer research with me, and I'm delighted to see that they post, they put my projects on their resumes, saying that we've done this and that. And students do recognize that. And I think that as we give students more projects, it makes things easier for the students to create their resumes, because they can put these projects on their resumes and really talk about them. And employers really like that, at the end of the day. In software engineering, we keep telling our students to do other projects so that when they do these projects, they can put them on their resume. But the problem is students are really busy. I mean, yes, if you're a software engineer, let's say, you're supposed to be coding a lot, but then you also have a life, right? There's other dimensions to your time. So I mean, it's kind of difficult to expect them that to code full time in school and then go home and then work on other projects. So then when I give them these projects, or they take projects in other courses, they're able to showcase these projects and build a portfolio for themselves, put it on their GitHub account and really take credit for these sort of larger projects. Because certainly if you're ever in an employer type position, you really, it catches your interest when you see people have worked on a project, because a project can have many different aspects that a simple assignment just simply doesn't.
I totally agree. And as you mentioned before, the decision to switch from teaching processing to Python, what led to that?
So a lot of that has to do with the data-centric approach that Schulich is taking. I think at Schulich, we are realizing that engineers need to program and need to learn programming because of data. Data is extremely important no matter what type of engineering field you work in. So civil, chemical, petroleum, electrical, there's going to be a ton of data, and successful engineers are the ones who are able to look at the data and make decisions. So Python, because it's used in machine learning, in data analytics, it has a lot of interesting libraries. It allows you to work with data quite nicely. And it's probably the number one language used for machine learning and data analytics, along with some others such as R and what have you. But Python is very powerful in that regards, and it makes things a lot easier for people who want to do data analysis. And we have a digital minor at Schulich, so it's sort of a digital spine that goes from first year all the way up, and we wanted 233 to act as the foundation of this digital spine. So everybody knows Python, everybody knows how to do some data analytics with Python, and then they go to these other courses for the digital spine, and they're able to perform. So this was a decision made to make sure that 233 is a little bit more data centric rather than just programming. So I can kind of go into the differences between teaching processing and Python. With Python is a language that is a scripting language, right? It's not even so much programming, that is scripting, and it does so much for you. When you teach people how to program, you're supposed to teach them algorithms. For example, you're supposed to give them an array, let's say 5 elements long or 5 billion elements long, and then tell them to sort it. And they're supposed to, write code. And there are different types of algorithms that you can implement, such as, merge sorts, bubble sort, quick sort, all these different algorithms that will give you different performance. So then I could teach a course on this. I could teach a whole course on this for a whole semester or even beyond. But the thing with Python is that it has so many powerful libraries that it can just kind of say sort, or you can just, it's just a lot easier to program in Python. So then as such, it becomes more difficult to teach programming using Python because it just makes everything so simple. It's almost like, teaching a math class with a graphic calculator, so it just makes things, it becomes more difficult to teach some of those algorithmic things. But I think we got a good mix of that in this course. And we were able to really sort of focus on the data part. So the project did involve data analytics and NumPy and all that stuff. So they were able to use some of these powerful libraries to be able to do stuff. And I think that's going to be an asset for them moving forward in their engineering career.
It's funny when you said that because the language is so simple that it's harder to teach. And as someone who did a lot of programming in Python before entering university, and then coming back to Python after learning processing and C, it feels weird. Python feels chaotic and very unstructured in its own way, just because it's basically anarchy. One of the examples that I will use is having to not put semicolons everywhere, and it's such a big, even that is such a big jump from C and processing.
For sure, and I tell you this. Let me elaborate on this a little bit more. So when you want to teach programming, if you ask a software engineer to teach programming, well, I'm like, okay, well, I can teach you programming, and where I would really double down and where I would spend a lot of my time, because to me, when I'm teaching people how programming, I want them to become programmers, right? So what I would do is that I would go to memory management right away to tell people how the computer structures memory. And then I would also go into algorithms to try to teach people how to write step-by-step algorithms and how to analyze them. So a best language for this probably would be C++, where you have pointers and you can teach people exactly what's happening in memory and draw that out for them. Now, if they say, okay, well, come and teach Python, then whoever teaches Python, let's say me, then we should make that decision. You should realize that Python is not the best language to teach memory management and teach algorithms and all that stuff, because it just makes so many things so much easier. You don't have to worry about pointers or anything else. You just write code and it does a lot for you in the back end. So when you teach Python, then I think you need to teach less programming because there's just less to say. It does everything for you. So then teaching Python, in my opinion, it becomes less of a programming class and more of a data class, where you say, okay, here is Python, here's you get started. Don't worry about memory management, don't worry about anything else. Here's you get started, and then let's actually solve more challenging problems in terms of data. Things that would take a C++ programmer days to write, you can write it, within 10 minutes because you just have access to all these like libraries and matrix libraries and all that stuff. And the fact that Python is not statically typed means that you don't have to say this is an integer, this is a double.
Yeah,
So
exactly.
it's like a free fall, and I mean there's a performance cost to that and all that. But that's basically what I mean. So when you teach Python, I think you need to step away from teaching a pure programming course. There are pros and cons to that, but I think there's definitely room for teaching a good Python course and to teach all those data principles or programming constructs so that people can kind of go and download the data and process it and visualize it and do all that fun stuff with it. So I think even though the constructs are more or less the same, you need to change your the way you teach programming when you move to a language like Python, and that's what was the biggest challenge for me teaching Python this semester.
Yeah, I don't think you realize how much, well, at least I didn't, how much the course is about memory management instead of anything else. And with Python, that's reduced very significantly. When you hear many students say that they don't care about the course or doing well in it because they're not planning on going into software or electrical engineering, what do you think of this?
Well, listen, I think that programming is, I think that's a valid comment to a point, right? I think that's a valid comment to a point that, you got to, first of all, you got to enjoy what you do, right? I mean, that's the most important thing in the world. At the end of the day, whatever you're doing in school, you're going to do so much more of it. So you really do have to enjoy it. And I think it's a fair comment for somebody to say that maybe they don't necessarily enjoy programming. But I would argue to say, first of all, like try to give it a chance, right? Try to give it a chance. And the other thing is, I'm not sure if there's anything in life that you don't use, especially programming. You never know. Learning is so important. Learning everything as much as you can. Engineers need to understand this. Like, there's nothing that you're not gonna need. Like, everything is gonna be needed in life. Even even math. Like, let's say we say software engineers may not need math. Well, listen, I went and worked for a lot of oil and gas companies doing a lot of simulation software, and I was doing calculus, and I was doing so much math and linear algebra, and I had to sort of pick that stuff up, and I had a clear edge over my computer science counterparts because I had done more math as an engineer. So you never know what you're gonna need a certain concept or a certain topic. Or another interesting thing, like, when I was in high school, maybe I would have said I don't really need social studies that much, or let's say concepts like psychology, maybe I didn't really care about. You come into software engineering, and psychology is a big part of everything. It is a big part of project management. It's a big part of how to deal with clients, how to deal with your boss, how to even design applications. So you need to pay attention to that. So we got to understand how everything kind of relates. I'm sorry for the sort of long-winded philosophical answer, but so I say we shouldn't dismiss knowledge, number one. Number two, we live in a very digital world. I mean, everything is on computers now. You produce data all the time. To be able to write code, write scripts, not even code, right? Write scripts to be able to get data automatically and graph it and plot it. That's a really valuable skill to have. I mean, that's one that's you want to be able to do stuff. So it's not so much programming. It's automation. As engineers, you need to be able to automate, and programming gives you that power. So absolutely everybody should be able to read and write code, and they should develop a vision of how they can automate tasks and automate learning from data. That's the future of engineering, and you got to realize it. I mean, you got to realize what game you're in, and you got to play that game. You can't fall behind. I mean, gone are the days where you just you didn't care about how much data there was, or you just sort of did things. I mean, things are changing. It's a very fast moving world, and you want to get every edge that you can.
And at the most fundamental level, I think, just like math isn't about learning number theory, I think programming serves to just have you develop your problem-solving skills. And I think even solving through simple problems like how to make a ball move across a screen made me think about the logic or the approach that I take to kind of solve all the problems in just all my courses and life in general, because, with programming, you need to understand how to solve problems before even, typing. For me, that was the case. I needed to kind of write out all of my thoughts and kind of solutions and my approach to a problem, and then do all the loops and then do all the coding.
Absolutely, absolutely. Yes, and being able to automate your tasks are so important. I mean, you show me any field, and I can show you so many different approaches that you can do to be able to automate those tasks and be able to make your life so much easier, and figure out ways to save the company money, and just understand things like in any field that you go, you're going to get sheets and sheets and megabytes and gigabytes of data, and then I've seen engineers go through this data using like dozens and dozens of Excel sheets, and it's just painful to watch and painful to work with. And if you just knew like a little bit of Python, you could just save everybody so much time. And I think optimization and efficiency should be at the part of your top of your list as engineers. People are going to love you when you save the company money, when you make processes more efficient. And trust me, programming is one way to do it. Probably the top way to do it.
I definitely agree with that.
You know what I mean? Like I urge everybody to be entrepreneurial minded if you're an engineer. And I'll tell you this. When you're in engineering, you're learning skills. Engineering is measured by dollars, by money. And I don't mean to sound like a huge capitalist of some sort, but engineers, we create value. So let's say you want to go to a village and you want to do pro bono work, and you want to give them clean water and whatever. You don't even want to make $1 out of it. Okay, that's completely fine. That's completely fine. But the value of your work is still measured in terms of dollars. So how much did you save in terms of dollars? So like our work is measured in terms of money. So like what value are we generating for the world? And the unit to measure that is dollars. So then engineers, you need to understand you're not professional students. Your goal isn't to pass these courses and get the degree. That's not your goal at all. Your goal is to try to learn skills that are going to generate value for you or for society or for whoever, whatever you care about. So whatever cause you care about, is it your own pocket or the society or the clean environment or whatever, what value can you generate? So you go into these classes and you learn those concepts with the mind, with how you can generate value. And I will throw at you another teaching term. It's called contextualized learning. When you learn something, you realize, how do other engineers use this to make money or to generate value? If it is the Fourier transform, whether it is balancing a load, whether it is a free body diagram, how do people generate value out of this? So, like scientists, they look at the concept and they study it. We look at the concept and we see, well, how can we do this to serve humanity, whether that humanity is your, is your bank account or somebody else's bank account, or just people in general. That's what you need to think about. So when you go to school, your goal is really not to get an A. That's just a nice thing to have at the end, and you will get an A. Your goal is, okay, well, how can I use this knowledge to be able to, generate more value? And you need to think about things that way. And that's why when I say you need to be entrepreneurial minded, because even if you work for a charity, you need to be entrepreneurial minded, meaning how do you use your resources to the best way that you can.
That is this is a very insightful conversation, because like you said, even when you're working for a charity, even when you're not taking in money to your own pocket for yourself, it matters how much you help people is measured in terms of money. And
Absolutely.
Many people, many students in my positions think of courses as just a requirement, just a method to get an A. And that, what you just said, is motivational, but also it doesn't stress you out. You want to do good, not because of the grade, not because of the value of that A or whatever.
Absolutely, absolutely. And at the end of the day, we go through the motions of school. When you come out of high school, I mean, you become a professional student essentially. Like you just take courses and then you get A's and you get B's, and then you're judged based on that, and they give you scholarships, and they don't give you scholarships, and they give you props, or they don't give you props because of how well you do. And you just, it becomes sort of a carrot almost that you kind of go towards. At first, they give you smiley faces, then they give you like high percentages, and they give you A's, and you just become conditioned with that, and you just kind of go through the motions. And I think the people who are really successful in engineering and other disciplines too is that they really understand what is the goal. Again, the goal isn't really to get an A, or the goal isn't even to get an engineering degree. I mean, look at all these people who make these companies, like the founders of Google or Bill Gates, or all these different people who kind of quit school and they go and they make these companies. Not that I'm advocating for people to quit school or anything like that, but I'm just saying, like, your goal isn't really necessarily to get an A in a course. Your goal is to learn. I mean, every course is an opportunity, because guess what? When you don't take that opportunity and you get disrupted because you have too many courses and life happens, what ends up happening is, after a while, when you graduate, then you got to go back and learn all that material, and that's time, and that's time wasted. So being entrepreneurial minded and looking at things in terms of resources, your time being the most valuable resource is the most important thing that you want to do. And then I don't want to sort of go on, and I want to sort of, if you have other questions, but do remind me to talk about sort of a balanced lifestyle at the end, because I think that's very, very important.
Actually, I will ask you about advice for general incoming students. But before that, I need to ask you a few more things. You've been involved in planning and delivering Schulich Ignite. Can you talk more about what Schulich Ignite is and how it helps students prepare for the engineering curriculum?
Absolutely. So Shulich Ignite started with an idea. Google had a program called Google Ignite, and Google Ignite was a program that Google would sponsor. So they would give universities some money, they would give the universities structure and material to create these programs to teach high school students how to program. They would give you the pedagogy of how you're supposed to do this. So for example, if I was going to do it on my own, I probably would just stand at front of the class and I would teach you how to program. But Google had said, no, we want you to do a mentorship structure, meaning that every 2 to 5 students would have a mentor, so that the mentor can help them out, and it's sort of a different than you just have a class. And so they gave us all those things, and we had to apply for it. And a colleague of mine brought this to my attention, Dr. Lale Behjat. Lale and I wrote this proposal together. And it also really focused on diversity. So how can we increase the number of women in engineering? So they wanted more women to sign up for these classes, and they wanted 50% of the participants to be women. So we started to advertise, and we started to advertise for mentors who are university students, and also high school students. And we got a really good leadership team back in 2016 together, and a team of students. They recruited students, and Lala and I were also involved. We delivered some lectures, and but then the students really sort of took over and did a fantastic job, and they became a club year over year. And for the last, since 2016, I think now it's and now we have very structured student club named Schulich Ignite. We rebranded to Schulich Ignite afterwards. At the time, we were one of the 4 universities in Canada that Google chose to give us the funding and the structures. We're very thankful for that, and they helped us out for the first year, and then they asked everybody to just rebrand and make it their own. And we did rebrand to Schulich Ignite. So we have graduated over 1,000 students, high school students so far, and the workshops essentially teach you how to program using a mentorship structure. So they're very hands-on. You show up to class, they give you a little bit of an introduction about programming concepts, and they give you a problem. You're supposed to work on it with the help of your mentors. So I think every semester we have something in the range of 30 to 50 undergraduate students who work as mentors and structure these classes. Our current club is just amazing. They're very structured. They have a very good guidelines in place, and they offer workshops in the fall, in the winter, and in the summer. And it's a great outlet for students, for high school students, to come see the university environment, talk to university students, get some mentorship, and develop some programming skills early on.
Yeah, and you mentioned about making the playing field equal. And in a previous episode, Shivek and Agam, who are the other content creators, talked about the lack of accessibility to these kinds of educational experiences, especially in programming. Obviously, not every school offers programming courses. And personally, unfortunately, my high school offered robotics classes, which I didn't take them, but I know some people who did and enjoyed it. But of course, Schulich has many students from all over the world, and it's definitely a challenge to try to level the playing field that way for everybody.
That's right. Absolutely.
And I think having gone through the program, I actually enrolled in Shulich Ignite before entering high school. Being able to look at the programming language and be mentored by someone who knows the language was,
absolutely,
even if I had already had some experience with Python before, it was great. It was a great experience, and I think it benefits everybody.
For sure, absolutely. I mean, the students who mentor benefit from that leadership experience. The high school students benefit a lot. I, as a faculty member who participated in it, I benefited quite a bit just by learning. So for example, Shulich Ignite, what we do is that instead of like an instructor going and lecturing for like, let's say, an hour and then getting people to do stuff, I learned that, you know what, it's good to just sort of get people experiencing things right away. So from there on, when I used to teach programming, I would kind of go and say, open up your laptop and I want you to do this. And I get people to just kind of program using the Schulich Ignite format. Of course, I didn't have all the mentors around, but just rather than going on and on about something, I would get people to open up their laptops and do something, and then let me do it and kind of go from there.
Yeah, you have published several papers on engineering education and developing creative, more engaging approaches to teaching classes.
That's
Where did
right.
the interest come from? What are the most interesting or key takeaways from these research findings? I think you've mentioned this, with the flipped classroom. You've mentioned a bunch of results you've gathered. But what lessons can students use to help themselves learn?
For sure. So great question. Thank you for that. So my PhD in software development and architecture and requirement analysis. And my background in industry, I worked in industry and I trained a lot of people in the industry back in the day. But I've had several startups or worked for different startups and smaller companies too, where we needed to train a lot of people. And a lot of times, because of cost issues, we would hire more junior people that we had to train them. And software process is really big too. So this whole training and teaching was a big area of interest for me, because that's another thing that you can generate a lot of value, where you hire a few people and you train them to develop software, and you generate value there. So, and I think that's a very important part of software engineering is to be able to train a team and make sure that the team is up to date. And that's how I became really, really interested in it. So it's not so much just the teaching aspect of it. I think that's very much at the heart of engineering. I'll give you a quick example. For Shulich Ignite, we have built a new platform. We built a platform that allows people to program right on the browser while looking at the stream of the instructor, and then allowing people to go into breakout rooms and talk with different people. We built this by help of a startup in Calgary, but then also mostly a lot of our own students. So last summer, I had about 14 people working on this project, all University of Calgary students, and we had to train them. And it was funny, we started in May, and I think May and half of June probably went into training. By about mid-July, it was like we had a whole software company. So we had generated value out of thin air. I mean, of course, all these students, they knew how to program, but they weren't familiar with the tech stack and the complexity of the project. But by mid-July, everybody was doing a great job. And it was like we had a whole software company. Like, we could have started a software company at that point. I'm actually like, that whole experience of how we came and trained everybody, and we were able to create a project. We're authoring a book on this that we're hoping to publish this year. I'm authoring this book with one of my research associates, who's a software engineering student here, Nusha Raisi Najad, and a PhD student here who works with Dr. Far by the name of Yusuf Mehdad. And it's a great experience that it shows how students learn and how we can teach them to be able to be successful in industry. The book is being written from three different perspectives: perspective of the interns, so Nusha. We had 14 interns, so she has collected all their experiences, and the experience of a professor. So I have taught all these people in different courses, and let's see how they do. So it was kind of like me being a fly on the wall while these guys were at their jobs, and what do they struggle with. And I looked at it, I said, I should have taught them this, or I should have taught them that. And the third perspective is from the perspective of the industry. So the startup that was helping us, or the company that was helping us develop this software. And so those technicians give us sort of feedback. So it's becoming a really comprehensive count of how we should really teach people. So the biggest thing that I got to tell you is teaching people how to learn. So providing them enough support, but then enough support that they're not struggling, but allowing them to learn on their own. That's the biggest thing. And then just hands-on teaching, hands-on learning, and making sure that the students develop the confidence to go forward. These are some of the biggest points that I see that we need to emphasize a lot more. I'm hoping by this summer. So we are in talks with the publishers, and we're still sort of working on a few chapters. It's pretty much done. Hoping by this summer, or maybe a little bit after the summer, we get it published. There's an interesting book called The Phoenix Project. The Phoenix Project it's like a novel of an IT project. So it reads like a novel, like you're reading a story, but it's about how an IT project kind of goes. And our project is kind of the same. We're calling it the Ignite Project. I think it's a working title, but essentially it's the idea that how do you train interns and how do you generate value out of it? And I think that same sort of philosophy we are putting into our software engineering program.
Yeah, and I think both educators and students alike would benefit from reading that book.
Absolutely. And industry too. I think industry, there are a lot of companies who sometimes hesitate in hiring interns because of how much upfront cost there is in training them. And I think that understanding how they can train interns, they can generate a lot of value from it. I mean, it's if you take the right approach, and if you put it, there's a capital cost you put in, but just investing in the people. So I think as a professor, I learned quite a bit from that project, and certainly the industry folks that I have talked to about this, and I have asked them to read chapters and give me feedback, they have definitely indicated that this is quite interesting for them.
So this is a question that you've been looking forward to. You've given us so much valuable advice, but any more advice for general incoming students that you would like to give in terms of managing workload, stress, or student life?
With the incoming students, I think two things: realizing what you want. Okay, are you here just because you think you're supposed to be here because high school is done and then you just got to do more schooling, or are you here because you actually have a goal? So be very candid with yourself. The hardest part of life, I've always said, is figuring out what you want. I mean, once you know what you want, then the rest is easy. Then you just do that. I mean, do you have a goal? You want to work towards that, or do you want to, relax and watch TV? And then there's nothing wrong with that. Do whatever you want, right? So be goal oriented. Know where you are. You're no longer in high school anymore. Like there's no, understand that you're here to be a professional. So you need to be budgeting your time. You need to understand that you're in a new environment. Know that there is a lot that you don't know. So tread carefully. Be very stingy with your time. Just be very mindful of your time and don't waste it. Don't go to this event and that event and the next event. Understand what you're trying to do. Focus on your courses. And once you pass first year with decent results, you can just rinse and repeat for the rest. You're just really gonna know what's going on. I think first year students can just be like a deer in headlights situation where they just come, there are all these courses and they're just not sort of successful. And then, what I've talked about, being entrepreneurial minded is extremely important. And one thing that I'll say, general advice to all students, first years, you go beyond, you don't realize how important this is. And this may sound cliche, but honestly, the most important thing in life is just being happy. right? I mean, being happy is the most important thing. And it doesn't really matter, if you're the CEO of Apple or if you just have like simple, whatever at whatever place. So try to have a very balanced life. I mean, life is short. You want to enjoy it. You're supposed to get enjoyment out of your work. Don't get burned out. I was a very one-dimensional person for a lot of years in my life. I gained a lot of weight. I would just sit behind a computer and code all day. And don't be like that. Go to the gym more. Make sure you eat well. That's really important. Just have a really well-balanced life. Make sure you have time to spend with your family. A little bit of time with your friends. Don't waste time, of course, but I mean, make sure you have some leisure time and just enjoy yourself, and make sure you think positive. Life is hard. Everybody's struggling. Okay. Make sure you always tell yourself that, yes, you can do it. You're doing well. Don't compare yourself with everybody. Like I shouldn't really sit here and compare myself with Zuckerberg and say that he's a billionaire and I'm, not a billionaire. I just get upset. And you shouldn't compare yourself with like this super 4.0 person and think that because you have a 3.0, you're losing. Life is not about that. Just enjoy yourself, be happy, be comfortable with in your own skin, and network, talk to people, learn from people, and just enjoy yourself, right? Your life is not going to start when you get your degree. Your life is now. So enjoy it now, and you're going to have different problems all throughout life. So you gotta be in the moment. Be in the moment, enjoy the moment, and live a really well-balanced life. And school and work is part of that. Get serious about it and just do really well.
Thank you. I've really enjoyed talking to you today. I think this concludes our meeting for today.
Excellent. I enjoyed talking to you too. Thank you.
Thank you. Thank you so much for sitting down with me and talking to me today. And thank you to everyone for listening. So yes, we will see you again in the next episode.